chance in the last class. The name of this game is craps. Okay, in this the user has to roll two dice, but they have to roll this dice only once. Okay, and what we have to take the sum of these two dice, right? So on the face, if it appear 3 on one and 4 on other, so the sum will become 7. Okay, so we have to take the sum of these two rolled dice. Okay, whatever appears on the face of this rolled dice, we have to take that sum, and depending on the sum, our game will proceed. Okay, so for example, we if the sum comes up to be 7 or 11, we will say the player won the match. If the sum comes up to be 2, 3, or 12, then we will say the player lost the game. And if the sum comes up anything from 4, 5, 6, 8, 9, or 10, then we will say that the player has to continue. Okay, the player is neither won nor he lost the game, he has to continue. But whatever comes up, that will be noted as a point. Okay, so suppose 8 comes up, so we will say the point of the player is 8. Now the player has to keep continue until unless he will not get 8 again. Okay, and in between if he gets 7, then we will say the player lost the game. Otherwise he will keep the game continue until unless 8 appears. So I hope the rules of the games are clear to you. And the important thing that I would like to mention here is this enum, which is a user defined data type. You can use this enum keyword to define your own data type. Okay, and then you can, in the brackets, in the curly brackets, you can mention what are the values that can be taken by this data type that you have defined. Okay, so in this I am defining status, and it can take these three values, any of these three values. Okay, and what happened in enum is this. So enum is actually a short form of enumeration. Enumeration is actually sort of symbolic constant. Okay, so whatever you write inside these are symbolic constant. And what are the value of this symbolic constant? So this enumeration will start indexing from 0. Okay, so continue, the value of continue is 0, the value of 1 is 1, the value of lost is 2. Okay, if there are more variables, so on and so forth, the value will increase one by one. Okay, so for computer, continue is equal to 1. This is sort of a symbolic variable, and the value of continue is 1, the value of 1 is 1, the value of lost is 2. Okay, so this is how you can mention. And whenever you use this word continue, the computer actually will treat it as 0. Okay, so what we are doing is, so this is just to increase the readability. Instead of just giving it 0, 1, 2 and so something like that, we are actually giving some keyword, okay, or some known names to it. Okay, so it is very much equivalent to our symbolic constant. And the way to define this is enum. You can give anything inside this. Okay, so here I am using some word, here I'm using some keyword sort of a thing. But you can use, for example, the rules applied whatever is true for symbolic constant, right? So you cannot start it with a digit, but anyways you can do so. That I don't think we will cover it later in the course. This is something which is out of the scope of this course. But if you are interested, you can have a look at enum or enumeration a keyword, which will let you know that what else you can do with this. Okay, but for now just remember that whatever you write in this by separating by comma separation, the computer will actually number it in this manner: 0, 1, 2, 3, so on so forth. Okay, and whenever you use this particular keywords in your program, it will actually replace by the value which is assigned to that constants. Okay, so in this, if we want to declare any data type, we will say enum status is game status. Okay, so game status will become a variable of status type which can take any of these three values. Okay, so now as rand is clear, this is we are giving seed to our random function. Now what this function is doing, so first of all it will roll the dice. What we need to do is we have to roll the dice. We need two variable, one is sum and one is my point. Okay, because whatever sum comes up by rolling this dice, we will take it in the sum, and depending on the value of sum we will continue our game. So there is a switch case on sum. If we get 7 or 11, then we will say game status is 1. Okay, and we will break. If the value are 2 3, or the sum value is 2 3 or 12, we will say we lost the game and we will come out of this. Otherwise we will say the game status is continue, and my point become the sum of this particular whatever the sum comes up, it that value is assigned in my point. Okay, and then we will come out. Now there is a while loop. We have to roll the dice again and again. So we are actually calling roll dice function 2 times in this program. Okay, one is in the very beginning. This is the calling of roll dice function, and second time it is a conditional calling. Okay, so if the game status is continue, then we will say okay, again roll the dice, and then we will at all the points we will compare whether now the sum is equal to my point. If yes, then we will say won the match. If the sum is equal to 7, we will say you lost the game. And if it is equal to something else, okay, then we will just continue this loop. We will come out of this loop only if these two conditions will met. Any of these two conditions will met, otherwise we'll keep rolling the dice. Okay, and in the end, if game status is 1, we will say player wins. If game status is otherwise, we will play print the player loses the game. Okay, so I think there is no problem with this particular example. In roll the dice, we already seen what we are doing. We have taken 2 dice, we are calling die 1 die 2, and we are generating a random function by using rand function, which is available in stdlib.h. Okay, and then we are returning here the sum of these 2 dice. This is what we are returning. Any question in this program? So this is the output. So if the player roll the dice and the sum is 11, then we will say player wins. If the sum is 5, we will say your point is 5. Now you have to keep rolling the dice until you get 5. If the player get 5, we will say okay, stop, player wins. And if in the very beginning, in the first roll only, your user get 2, we will say player loses the game. Okay, any question in this? So here actually we are making use of function calls, switch cases, loops, and one more new concept that we have learned, that is this enum, enumeration constants. Any question? Yes, any question, or should I continue? Okay, just unmute, some of you unmute your mic so that I am knowing that okay, there is no connectivity issues. All right, so let's now move to our next topic. Okay, so one more important thing I would like to mention here is, since enumeration constants are equivalent to symbolic constants, right? They are more or less same as symbolic constants. So please note that if you try to assign some other value to this constant, then it will be a syntax error. Okay, if you remember, we cannot assign any value to symbolic constant. We can only use them to compare it, compare their value. So same is true with enumeration constant as well. actually we have defined the value in the very beginning. Now you cannot change the value of these constants. Okay. And there is this good programming practice which says that, okay, just keep all the letters which you write inside this in uppercase, just to make it stand different from the normal variables that we are using. Okay, and this is true for symbolic constant as well. If you are defining one symbolic constant, then try to keep it the case as uppercase. If you are doing it using enumeration, then also try to make it all in uppercase letters. Okay, just to make it, or just to let it stand different from other variables. Okay, so now let me move to another topic of today's class, which is storage classes. Now, what are storage classes? So we have till now discussed identifiers, and for us, identifiers are actually variable names. Okay, but identifiers are also like function names, variable names, and other many types of variables also, right? So let's see what actually what are the attributes of this identifiers. So till now we have seen these four attributes. Okay, so let's talk about the variable name only for now. Okay, so a variable name has these four attributes. If you remember, a variable should have a name. Okay, so for example, if I write int x equal to 5, so this is the name of the variable. Then we have a type, so this variable is of integer type. Then we have a size. Okay, so there is some size defined for x. So since we are writing int, so this is a signed int, and depending upon the architecture of the computer, there is a fixed size of this particular x which is given to it. And then there is this value of the x, the variable. Okay, so these are the attributes that we have already seen, but there are few more attributes which are related to identifier, and those attribute includes storage class. Okay, the type of storage class, we will come to this, what is this. Then there is this storage duration, then the scope of the identifier, and linkage of the identifier. Okay, now what is storage class? Storage class could be auto, register, extern, or static. Okay, these are the four types of storage class that any variable can have. Okay, so what actually storage class will determine? Storage class will determine these three things. Okay, depending upon the storage class, we can define what is the storage duration of the variable or identifier. Okay, so what do you mean by storage duration? It is the period during which the identifier exists in the memory. Okay, for how long the identifier will exist in the memory, whether the existence of this particular variable or identifier is throughout the program execution, or whether it will just create, after some point, and then it will get destroyed. Okay, so this is defined by the storage duration, for how long the variable or the identifier in general will stay in the memory. Am I making sense? Yes or no?
Yes,
Yes,
ma'am.
ma'am.
Then storage class also determine what is the scope of the variable. Okay, so scope is, where we can use that variable, where that variable can be referenced. Okay, where that variable is known, right? So if you use the variable, or if you write a variable, out of the scope of that variable, then the compiler will say, I don't know this variable, this variable is not known, or it is not defined, or something like that error you will get. Okay, so storage duration means how long the variable stays in the memory, and scope means where we can use that variable, what is the scope of the variable where it can be used. And linkage is something related with, when we deal with multiple source files. Okay, so I think in cp we will not cover multiple source files. Okay, but later when you study any other programming languages, then you will see the use of multiple source file. Okay, and there this linkage will come, but this linkage is also defined by storage class, right? So storage class specifiers are auto, register, extern, or static. Okay, so let's see in detail what are these classes and how they are categorized even further. So the main thing in this slide is this: storage class determine what is the duration, storage duration of the identifier, what is the scope, and what is the linkage. Okay. Okay, so yes, scope is whether the identifier can be referenced in the program. Some can be referenced throughout the program, whereas other can be referenced only in the small portion of the program. And linkage determine the use of this particular identifier into multiple source files. Okay, whether the identifier is known only in the current source file or any other source files as well. All right. So this is what defined by storage class. Now storage class specifiers can be divided into two broad categories. We have already seen these categories when we are discussing storage class about arrays. Okay, these categories are automatic and static. Automatic storage duration and static storage duration. So if you remember our array example, we have seen there two types of declaration in that. One is automatic local array and one is static local array. Okay, array. So same applies here as well. So these variables can be automatic or static. What is the difference between automatic and static? So if you want to make a variable automatic, then you can use this keyword auto. Okay, and if you mention this keyword in front of any variable, this variable will automatic storage duration will created when the block in which they are defined is entered. They exist while that block is active and they are destroyed when the block is exited. Okay, so this is the property of auto storage duration. Are you following me?
Yes, ma'am.
If I say auto int x equal to 5, this means that this variable x will be created only when this line will get executed. Before this line, there is no existence of this variable x. So whenever this line is called, it will get active, and whatever is the block within which this line is mentioned, it exists only within this block. Okay, whether it is a function block or a file block or anything else, so it will active till the block remain active, and once we will come out of this block, there will be no existence of x. Okay, so it exists only within this block. So all the variables that we have seen, they are by default automatic storage duration type. Okay, so local variables, only variables can have automatic storage duration. So a function's local variable, those declared in the parameter list or function body, normally have automatic storage duration. Okay, we have already seen this, that when we will define a variable into the parameter list or inside the body, the scope of that variable will is only within that particular block. Okay, so I am right now not talking about scope, I am talking about storage duration. So the storage duration of those local variable is when we entered into the function, those variable will be created, and when we come out of the function, those variable will be destroyed. Okay, so the creation and destruction will happen very frequently in case of local variables. So by default, all the local variables are automatic. If you want to make any particular variable act like this auto, then you can mention auto explicitly. Any question till here? So we have just covered one specifier, that is auto, and this auto is of automatic storage duration. Okay. All right. Scope we will talk little later. Right now I am just talking about storage duration. Now, local variables have automatic storage duration by default. Okay, so we are generally not using the auto keyword, but if you want to write it explicitly, then you can do so. Okay, so automatic variables are the default variables. If you just write int x equal to 5, this is automatically will become auto variable, automatic variable. Okay. So automatic storage is well known for conserving the memory. Why? Because if there is no use of that variable, it will not exist. Means if you will come out of the scope of that variable, then it will not exist. Okay. So it is known for conserving the memory. So if you have to make a program in which memory is important, you have to conserve as much as memory as possible, then try to use as much as automatic storage as possible. Okay. All right. Now let's come to static storage class. So in C, static storage class can be used by these keyword extern and static. Both can be used. Okay, there is a some difference between these two, but that we will see later. But from the point of view of duration, both are same. Storage duration. Okay, so if for any variable we mention external storage class or static storage class, then what happened? This static storage duration exists from the time at which the program begins its execution until the program terminates. So those variable exist for the entire duration of the program. Where it can be used is a separate issue. Right now, I am just talking about their existence into the memory. Okay. So if you define a variable as extern or static keyword, then they will exist from the beginning of the execution of the program, and they will remain in the memory till the program terminates. Are you following me here? Any question?
मैम हम जब किसी चीज को इनिशियलाइज करते हैं तो वो स्टैटिक में काउंट होगा कि ऑटो में, क्योंकि जीरो जैसे हमने आई को जीरो असाइन करा तो वो तो पूरे प्रोग्राम के टाइम पे रहेगा ना.
So if you assign I equal to 0, then you have to mention what is the storage class. If you will write only int, then this will become automatic storage class, and it will not remain entirely. Okay, it will just come into existence when this particular declaration will be there.
जैसे हम अगर हमने फॉर लूप लगा रखा आगे और अगर कंडीशन सेटिस्फाइड नहीं हो रही है तब तो आई जीरो ही रहेगा ना.
We will see the example, then the things will be much more clear. Okay. For now, please remember, if the variable, the storage class of a variable is automatic, then it will exist in the memory only for some duration. Otherwise, it will not exist in the memory. And if the variable is defined as static storage class, then it will remain in the memory for the entire execution of the program. Okay. In the example, we will see where we can use it and where we cannot use it. I am just talking about where it exists, whether it exists in the memory or not. Okay. So for static variable, storage is allowed, storage is allocated and initialized only once before the program begins its execution. If you remember the example of the array, once the sentence, the definition will come, what happened? Some value is assigned to it. And now the again and again the initialization will not happen because that variable remain in the memory. Okay. All right. For the function, yes, any question? Okay. For functions, the name of the function exists when the program begin execution. So function names are also identifier, and they are by default static identifiers or static storage class identifier. Okay. They remain, these name remain from the beginning of the execution of the program till the end of the execution of the program. Okay. Now, however, even though the variable and function name exists from the start of the program, this does not mean that these identifier can be accessed throughout the program. Okay, so accessing the identifier is a different issue, and existence of that identifier in the memory is a different issue. Till now, we have mentioned two things, that if the class is automatic storage class, then it will exist in the memory only for a small duration. If the class is static, okay, that can be made by the keywords extern or static. So if the class is static, then it will remain in the memory for the entire duration. Okay, now let's talk something about scope. Okay, so we will in couple of minutes we will see what actually scope is, but storage duration is clear. Okay,
Yes,
and if
ma'am.
you want to know the difference between extern and static, so let me just clear in very short what is the difference. So extern, actually these are the global variables. If you write extern keyword in front of any variable, this will become global variable. Okay, and static is again a local variable. Static is again a local variable with some constraints. Okay, so we will talk about it when we talk about scope. So for now, yes, to write static storage class, we can use extern and static. Okay, all right. So if you mention a global variable by default is of extern type. Okay, so if you define a global variable, then automatically the type will be extern. There is no need to write it extern explicitly in that case. Okay, so global variables and function names, the storage class is extern by default. Okay, and there are several type of identifier with static storage duration. So if there are local variables declared with the storage class static, they can be remain in the memory for longer. Okay, so these are few difference. Now let's talk about global variables. So global variable, how to create a global variable? What you need to do, just place the declaration of the variable outside any function. If you write something inside function, it will become by default the local variable to that function. If you place something outside function, then the variable declaration become global by default. Okay, and they remain in the memory throughout the execution of the program, because global variable, the type of the storage class of global variable is external. Right, so before is starting the main, so suppose you are starting your main function here, what you need to do, you can just do x equal to 5 here. Okay, before the main function or out of the function, then this will become global variable, and it can be accessed inside or throughout the program. It can be in the memory throughout the program. Okay, scope we will talk. So global variables and functions can be referenced by any function that follow their declaration or definition in the file. Okay. Now this is the reason why we place our stdio.h in the very beginning of the program. Okay, because there is this function printf which is defined inside stdio.h, and we want the printf to be used, okay, throughout the program. Therefore we try to place it at the top. Now in this slide there is one very subtle thing that you should notice. See, global variables and functions can be referenced by any function that follow their declaration or definition in the file. Okay, so this is an important point. So if I mention a function, suppose I am mentioning a square function, and I am writing this square function after main without writing any prototype, what happened? I cannot access this square function inside main function. Why I cannot access it? Because these global variables and functions can be referenced only by the functions that follow their declaration. So anything which we write after this declaration, after their declaration, there we can use it, but we cannot use it before. Are you following me? Okay.
Yes, ma'am.
So even if we are writing a global variable, so suppose this is our main function and we define our global variable somewhere here after the main function, but before defining any other function, before defining say square function, then we cannot use x here. This is not allowed, but we can use x here. Okay, so although the x is a global variable, but it can be referenced by any function that follow their declaration, that is written after their declaration. Okay, and therefore function prototyping is important. Function prototyping is allow us, okay, to use that particular function anywhere in the file, because in the very beginning we will write our function prototype. Right? So this is one reason for using function prototype. When we include stdio.h in the program that calls printf, the function prototype is placed at the start of the file. Okay, because the function prototype is mentioned in this header file and it will get placed in the very beginning, which allow us to use printf in the entire program. So where you are placing these things also make a difference. Any question in this slide? Yes?
No, ma'am.
Yes.
No, ma'am.
Okay. All right. So defining a variable as global rather than local allow unintended side effect, because if you make a variable global, then it can be used throughout the program and it can be modified by any function. Okay, so if there are the variables that can be modified by multiple function, then we will say that we have to keep our calling and all very carefully, just to avoid intentional or unintentional modification of the variable. So in general, don't use global variable until unless it is very much required. Okay, right. So variable used only in a particular function should be defined as local variable to that function rather than as external variables. Okay, so if you define a function inside a if you define a variable inside a function, it will become local variable. If you define a function out, if you define a variable outside the function, then it is known as global variable. Okay, or external variable. Okay, now local variable declared with keyword static are still known only in the function in which they are defined. But unlike automatic variable, static local variable retain their value when the function exited. Okay, so what is the difference between static and automatic variable? So if I say, so in the function, let's say square function, I define static int count equal to 1. Okay, and then I'm suppose increasing the value of count. What will happen when we call this function for the first time? The value becomes 1. Okay, and then we will increase the value, so the value becomes 2. Next time when we enter into this function, we will not initialize this value. This initialization part is over. We will now just increment the value by 1. Okay, so the value becomes 3, 4, something like that. Okay, but if it is a local variable, then each time the value will get initialized by 1. So this is the difference between static local and automatic local. We have seen this particular program in the array as well. The rules are exactly same. Okay, static local variables retain their value when the function exit, whereas automatic variables, there is no existence of the automatic variable. So whenever you come again in the function, you have to create that variable, and therefore you have to again initialize the variable. Okay, any question here? Okay, so all numeric variable of static storage duration are initialized by 0 by default. We have already seen this in array as well. Okay, so if you will not initialize the static variable, it will get initialized by 0. If there is a static local array, and if you will not initialize that array, all the elements are automatically initialized by 0. But this is not true with local variable case or local array case. Okay, right. Now let's talk about the scope rules. So what is the scope of an identifier is defined by the portion of the program in which the identifier can be referenced or is known. Okay. So there are 4 types of scopes for any variable. Okay. So the the identifier is either having a function scope, a file scope, block scope, or function prototype scope. Okay, and here also this is true. When we define a local variable in a block, it can be referenced only following its definition. Okay, so this is true for all the variable. Whenever you define the variable, after that only you can use it depending upon what is the scope of the variable. Okay, so let's talk about these 4 types of scope. Okay, I think function scope is clear to you when you define a variable inside the function, right? So the scope start from this curly bracket and it will end with this curly bracket of the function. Okay, so file scope is quite same to this. Okay, I don't want to explain labels. Labels is having actually the function scope, but let's not go into that. Okay, so for simple example, if I am having this square function again, I write int x equal to 0. Okay, I can use this x only inside this but particular block. After this, if I try to print x, okay, then it will not get printed. The scope is only within this function. This is called function scope. What do you mean by file scope? If the variable exists, or if I can use that particular variable throughout the file, okay, all the functions which are written in the file, just remember that the scope starts once you declare the variable. Okay, what is block scope? So block scope is something, so you know, if you start this particular curly bracket, you define some variable here, the scope of this variable remain only till it reach to this right bracket, corresponding right bracket. Okay, so this is called block scope. It cannot be used even inside the entire function. Okay, so if I am having a square function, there are few statements here. This is the starting of square function. There are few statements here, and if after some time I put this bracket and I say int x equal to 5, and then I close this bracket, and if I try to use this inside this function but outside this block, it cannot be accessible. Okay, so this is called block scope, and block in C is defined by this curly brackets. Okay, and there is this function prototype scope. Function prototype scope is very simple. So when we define the function prototype, okay, we generally write something like this, int x, right? So this is also a variable, but the scope is kind of nothing. Okay, this is called function prototype scope. It is okay if you don't write this variable, you just refine the data type, then also it is okay. Okay, so the function prototype scope are those used in the parameter use list of function prototype. And as mentioned previously, function prototype do not require name in the parameter list, only types are sufficient. If you use the name, then actually compiler ignore that name. Okay, so there is no existence of this name. So this is called function prototype scope. So if you write x, it is equivalent to you are writing nothing. Okay, so the scope of this x is actually only inside the function prototype, nowhere else. Okay, so any question here? Okay, now let's see this programming error. Yes, yes, please.
Ma'am, in the function, if we write the static variable, then also it will not work if we do the execution outside that
Yes, if it is
function.
a variable and defined inside the function, then it will not work outside the function. Okay, and those are called static local variables. So let me just give you one example. Okay, in this example, everything will be cleared, whatever we have covered till now. So just pay attention in this particular program. This program is little bit confusing, and therefore I have already shared this program on the classroom. Okay, now let me explain this. In this program, what we are doing is this. We will make use of local variable, static local variable, and global variable. Okay, all these variables will be used. Now let's see what happened. So first of all, we are defining at line number 9, we are defining a global variable. Okay, what is the value of the global variable? What is the value of the global variable?
One.
Yes, the value is 1. Okay, and why this is global variable? Because we declare it outside any function. Okay, this is not, this line number 9 is not inside any function, and therefore it becomes a global variable. What is the storage class of this global variable? Extern. Okay, by default it is extern, and from now onwards this variable will be accessible. This variable will be accessible. Okay, now let's start our function main. Okay, so when we enter into the function main, what we did is this: we define one more variable, the name of that variable is x, and the value of that variable is 5. Okay, so since we declare another variable, this x will become local variable to main. Are you getting my point? So first of all, x is a global variable. One x is a global variable. This is a global variable, and the value of this variable is 1. Okay, so maybe I will write something like this. This is variable name, and this is the value. So x is a global variable. If this is a global variable, this is different. Okay, so let me call it as this xj. I am just writing to let you know that this is a global variable, and the value is x. When we enter into a main, one more variable will create it. Okay, and this is inside the main function. This is a local variable. Okay, this is a local to main, local to main. And what is the value of this particular x? The value is x. Right? Now what happens? See, now we are just printing local x in outer scope of main is this. Okay, now what we are doing, see, we are placing one curly bracket here and one curly bracket here. Inside this, again we define a new variable called x. Again the name is x. Sorry, the name is x. Okay, and this is also a local, but it is having a block scope. Okay, local variable with block scope. This x is accessible only within this block, and the value of that variable is 7. Are you following me here? Yes or no?
Yes, ma'am.
So actually we have defined three variables. Although the name of these variables are same, but they are having different values and different scope. And depending upon where we are using this variable, accordingly those values will get printed. Okay. So now let's see what will happen if we run only this part of the program. Okay. Now what happen is this: when we write this line, local x in outer scope of men, what will get printed here? What value will get printed in this line?
5.
Yes, the value printed is 5. Okay, so this line will print 5 value. We will cross check it. There is the output of the function as well. So the value is 5. Why it is 5? Because the here x is actually a local variable and the value of that local variable is 5. Okay, so whenever you use the x for printing, what happen, whatever nearest value or whatever nearest variable name in the scope, that will get printed. Okay, so if I am printing x, then this particular value will get printed. When I print it inside the scope, okay, inside this brackets, what value will get printed? This print line will print
7.
7.
okay, and just after this line I am again printing the value. What value will get printed here? This is inside main function. Okay, the main is not end till now. What value will get printed?
5.
5.
Okay, and hence we can say that this variable is no longer existing. This variable is no longer existing. The existence of this variable finished once we came across this particular block, right bracket. It will no longer exist and no longer can be used. Are you following me here? So this is the difference between local variable and local variable. Both are local variable. This x is also local variable, this x is also local variable, but this x is having a function scope and this x is having a block scope. Okay, all right, so this is one thing. Now let me show you the output till here. Okay, so this is the output of first 3 lines. Okay, we will print 5, 7 and then 5 again. Okay, so these 3 lines will actually show us the difference between local variables with function scope and local variables with block scope. Any question till now? Okay, now let's move forward. Now what we are doing is this: in the main function only we are calling use local function, use static local function, use global function. These 3 functions. Again we will give a call to use local, use static local and use global. Okay, this is what we are doing. Now let's go inside this function and have a look what is written in there. Okay, so in use local we define again yet another function, x equal to 25. So when we come here, x will become 25. This is a local variable and it is local to use local function. Okay, it is local to use local function. What we are doing is we are printing the value. What value will get printed here?
25.
25.
25. We increase the value and again print it. What value will get printed here?
20,
26.
26.
26. Okay, so when we call this for the first time, 25 will get printed, 26 will get printed. Any confusion here?
No.
I think. Okay, now let's call static local. When we call static local, what happened? Static local, okay, the x becomes 50. So this is static local. to use a local variable with static, whatever, something like this, and the value is 50. Okay, fine. So what will get printed here?
50.
50. Okay, because x equal to 50 now. We will increase the value by 1 and again we will print the value. What will get printed here?
51.
51. Okay, so far so good. So we are done with this calling as well. Okay, we have called it and 50 will get printed, 51 will get printed. Okay, now we will make a call to use global. Okay, in use global, now let's see what we will do. So this is our use global function. In use global, we are not initializing any new variable. If you will not initialize any new variable, this x will refer to the global variable because there is no other x which are accessible within this scope. Are you getting my point? The scope of all the x that are defined previously is lost. Only one x is remaining, that is the global x. Okay, and therefore what this particular line will print?
1.
1, because the value of global x is 1. What we are doing, we are changing the global value, we are multiplying 10 to it. Okay, so what will get printed in this line?
10.
10. Okay, till now any question? So we are done with this call also. So one time we have called use local, use static, and use global. Okay, now let's see what will get printed. So it is 25, 26, 50, 51, 1 and 10. Okay, so you can see 25, 26, 50, 51, 1 and 10. Okay, till now we are done with the first call to all the function.
Ma'am,
Okay. Now let's have a look at second call. Now
ma'am,
second time I called use local. Just a minute, let me complete this program. Okay. Now second time I will call use local. Now what will happen when I enter into the use local? Okay. So when I move out of this, what happened? This X was destroyed. This X was destroyed. And since the X was destroyed, when we execute this particular line, again it will get created. Okay, and what will be the value of this? What will be the value of this?
25.
25.
Right, right. So again, if we print 25 will get printed and 26 will get printed. In the second call, I am talking. All right. So in the second call also the same value will get printed. So let me write here about the second call. In the first call also we get 25, 26. In the second call also we get 25 and 26. Okay. Now let's call use static again. So if you remember, even if you come out of this block, the variable will not get destroyed. It will still remain in the memory. Okay, and therefore this line will not get executed. Initialization is already done in the very beginning of the program. Okay, so what value will get printed in the second call? What is the value? What will
51.
we will print 51. Then we again increase the value by 1. Okay, in this line again the value will get increased, and what will be printed by this line?
52.
52. Now can you see the difference? In case of local variable, first call and second call have same impact, whereas if you define static local variable, in the first call initialization will happen, but from then onwards whatever changes you will do into that variable, that will persist even in the exiting of the function as well. Okay, so the value which will get printed is 51 and 52. Now let's call use global again. So this is the second call for use global. Now what is the value of global variable x? When we execute this,
1.
yes, what is the value? What is the value of the global variable?
1.
1.
Why 1? Why 1? When we are executing this line, where these changes occur? Where these changes occur? This actually changed the value to 10 because this is a global variable. Are you getting my point?
Yes, ma'am.
Yes, ma'am.
Yes,
Yes, ma'am.
global variable, right? So the value get already changed when we first execute this function. So now the current value of global variable is
10.
10.
10.
And again we will multiply 10 into 10. So this line will print
100.
100. Okay, and it will also change the value here. Here also the value become 100. Okay, so after execution of this particular function for the second time, anybody will execute x global x or x's global x, the value it will get is 100. Okay, so now you can see the output. For the local it is same 25 and 26, which is same for first call and second call. In case of static, the value retains. Okay, and in case of global also the value retains. Okay, and after this function, sorry, after calling all these functions, again I am printing the value of x. What will get printed here? So again this is inside the main function, and inside the main function the local variable is having the value 5. Okay, so this line will again print a 5 and the program ends. Okay, now